Okay. All right, guys, angle of inclination. This is a specific type of angle. All right, that's the name of the angle. So I've written down the definition, but I'll obviously show you on the diagram. There's two diagrams here, so I'll show you exactly where that angle is. The angle of inclination is the angle between a line and the positive x-axis. So guys, we have the x-axis over here, right? This is the negative x-axis. Because those x values there will be negative. Right? Do we agree? This is like an underline. If we have 0, the x-axis, the positive x-axis is this one. Now the line doesn't always have to cross the positive x-axis, okay? The line can go over there. It can go through the negative x-axis. But the important thing is that the angle is always coming from the positive x-axis. All right, so if you copy down this diagram, the first one, you can just take a different color pen and you can just put in where that angle actually is. It is between this line and the positive x-axis. So we're going to from the positive x-axis, or at least just from the direction, from that direction, basically from the right-hand side. And it's always coming from the right, never from the left, always from the right. This angle we can call theta. Okay, that will be the angle of inclination. You know the symbol theta is like a 0 and you just do a line through it. It might not be super clear there. Now the formula for angle of inclination, you have to memorize this formula and you have to use a calculator for it. I'll just write it on the side. The formula is that tan of theta, or whatever the angle is, they might call it x, they might call it beta or alpha, whatever. Tan of the angle is, what am I doing? Sorry. So I've been making mistakes all day. Okay, so must be an M, not the symbol that I was trying to make there. Tan theta equals the M. And what is M, right? We've worked with that before. M is the gradient. All right, so tan theta, so tan of the angle is always going to be the gradient of the line. Okay, so we're going to actually practice this on the right-hand side here. We're going to calculate theta using this formula. Okay, but this formula you need to memorize, right? That is the formula for angle of inclination. Okay, so if they're asking you to find this angle, you are going to say tan of theta is equal to the gradient. Now guys, sometimes you'll see tomorrow we're going to do examples where you have multiple lines, maybe lines that cross. Then you're going to have to say the gradient of AB, for example, the gradient of CD. All right, you're going to have to label that gradient. You'll see tomorrow when we're doing the examples together. Well, now there's just one line, so we can just write gradient. Okay, it's obvious that the gradient is going to be this line. All right, we're going to have to calculate the gradient. We have a formula for gradient, right? Changing y over changing x. So we're going to do that. For this one, we're going to say, let's start with the bottom one and we minus the top one. So we say changing y, negative 1 minus 1. All right? Negative 1 minus 1. Never mind. Never mind. So that was rough. I just go to that here. Okay, negative 1 minus 1. Sorry. And then this one changing x. 0 minus 2. What's negative 1 minus 1? Negative 2. And at the bottom, we also get negative 2. So that gradient is 1, right? It's negative 2 or negative 2. The answer is 1. So tan theta is 1, but we haven't calculated theta yet. Do you guys remember last year when you did trig? Right? You have to do shift tan of that number. Do you remember? So now we're going to say theta is equal to, and what you write down is tan to the negative 1 of that number, whatever that gradient was, right? So shift tan. So what you type into the calculator is you press the shift button, then you press tan, and then you press 1. And the answer is 45 degrees. And that is the size of that answer. Okay. Next example, I'm going to move down so that you can copy down the next diagram. All right, I'm going to pull the angle of inclination here. Now, guys, I know you're probably still busy, but if you can just look at this quickly. Angle of inclination is always the angle between the line and the positive x-axis. So it's always coming from the right-hand side. So the angle of inclination in this case is going to be this obtuse angle that I have over here. Let's call it beta now. All right, let's use a different angle. Not theta, it's beta. We're going to calculate another one. I'm just going to write the formula so long. In this case now, the angle of inclination is beta. So we're going to write tan of beta is equal to 30. Right, whatever they call that angle, that is what you have to use. Sometimes, guys, they give you a question with multiple angles and they don't name those angles. Then you have to name them different things. Okay, you can't work with two thetas or two betas or two x's or whatever. Right, we'll see tomorrow when we do those examples. Okay, so now I need to find the gradient of this one, just like we did before. Okay, tan of beta is equal to the gradient. We're always going to have to find the gradient. All right. So again, we're going to do change in y over change in x. Let's again do the bottom one minus the top one. So we're going to do change in y, -1 minus 1. Right, -1 minus that one, which is 1, over change in x, 3 minus 0. This x value minus that x value. Put it on the other way around. As I could have said 1 minus -1 and 0 minus 3, you'll get the same answer. Okay, what do I get here, guys? At the top I have -2, and at the bottom I have +3. So this gradient is -2 over 3. Now, guys, our calculation is going to be different in this case, right? Let me just show you what happens if you just do that calculation. What did we do in the previous one? Now when we want to find the angle, we do shift tan of this number, right? That's what we did here. We did shift tan of 1, and we got 45. Now, guys, if you now try to do shift tan of -2 over 3, what's going to come up is not actually going to be the answer. So I did shift tan -2 over 3, and I'm getting a negative angle. Right, that can't be. We can see clearly on the diagram, this has to be an obtuse angle. All right, so what you're going to do, and we're going to use this method quite a lot in trade when we do trade later on. When your gradient is negative, right? So I'm going to write here negative gradient. Then you are going to find the reference angle by calculating shift tan, so I'm going to say tan to the negative 1, of positive 2 over 3. Something you're going to have to remember. If your gradient is negative, you are going to ignore that negative at first. We're going to do shift tan just of the number, of the positive number. And you're going to label it like this. You're going to say RA, reference angle, is equal to, you are allowed to write RA, that's fine. Tan to the negative 1 of positive 2 over 3. All right, so I'll show you what we get. Shift tan of 2 over 3. And there we get 33,5, sorry, 69 degrees. All right, 33,69 degrees. Now, guys, this also can't be the answer, hey? We agree that this must be an obtuse angle. Now, the angle that we actually getting here, this 33,69 degrees, is actually this one. The acute angle that is next to beta. Okay, that is actually the angle that we're getting. It's almost like we're calculating an angle of inclination from the wrong side, because we're changing that sign. We're changing that negative sign to a positive sign in our calculation, so we're actually getting that angle. All right, so I'll just make an arrow going here. And that's why that angle, what was I doing to get beta? 180 minus, good. So therefore, beta is equal to 180 minus 33,69 degrees. And the answer is, I'm going to trust myself to even work that out, 146,31 degrees. So when you have a negative gradient, you're going to have to do more work. Right, you're going to have that extra step when you first calculate your reference angle by using the positive value. And guys, in some questions you'll see tomorrow, sometimes they want you to calculate, or you need to calculate this angle, not the angle of inclination. Sometimes they actually going to need this one. Then you'll just calculate the reference angle. Right, if they ask you for the angle of inclination, you have to say 180 minus. But guys, for analytical geometry, you don't really have to write reasons, but sometimes it's good just to do it so that we remember what those reasons are. So angles on a straight line. Try to watermark for that reason, but it's good fun just practicing it. Okay, so those are the two types of questions that you're going to get for today on angle inclination. Right? If the gradient is positive, it's easy. You just calculate that gradient like we did here. You do shift tan of that number, and that is your answer. If your gradient is negative, you are still calculating your gradient like we did, doing change to y over change in x. Then you find your reference angle by ignoring the minus in your shift tan calculation, and then you subtract that from 180. A lot of people prefer to actually, instead of writing this as two separate steps, right? You could just write beta is equal to 180 minus shift tan of 2 over 3. You see if that makes sense? That's basically what we did. Hey, we did shift tan 2 over 3, and then we subtracted it from 180. But a few people prefer to just do it all in one step. Just if you see that it's an obtuse angle that you're finding, you know you're going to have to say 180 minus the reference angle always. So you can do it like that, 180 minus the reference angle. Okay, in one step. And then you can even type it into the calculator like this, and the answer will come up as 146,31. Okay, now sometimes you don't have to calculate the gradient. Sometimes they give you the gradient, which is actually what they do in the exercise in the textbook. So I'm just going to write down the exercise and then I'll show you what it looks like. So I would like you to do exercise 2. on page 66. Numbers 1, 2. No, let's just do 1 and 2 for today. We'll do number 3 tomorrow. Just write that down quickly, then I'll show you what those questions are. Okay. In this exercise, we're not looking at number 3 now, you're just going to do 1 and 2. In 1.1, they're saying, well, in number 1, they're saying determine the angle of inclination of line AB where the gradient of AB is given. All right, so they're telling you in 1.1, the gradient is 2. Right, you don't have to do change in y over change in x. They're telling you what that value is already. So what you're going to do for that one, you're going to say tan of, and they're not telling us what the angle is supposed to be called, so let's use theta. Tan of theta is equal to m, but now they're telling us that m is 2. So for this first one, we can just go straight to tan theta equals 2. Right, we don't have to do that first step where we find the gradient. They've given us the gradient. Okay, do we understand the difference? We're literally saying m equals 2. And now from there, you're going to say theta is equal to shift tan of 2. Type that into the calculator, and that is then your answer. And you can tell your answer. For the next one, the gradient is -5. So you're again going to say tan theta equals -5. But when your gradient is negative, find the reference angle and you subtract that from 180. Okay, so we're going to do that for the first 4. In number 2, it's slightly different, guys. Let's look at 2.1 here. Determine the angle of inclination of these lines correct to one decimal place. Now they've given you the equation of the line. They're not telling you explicitly m is equal to this. Right, so we remember the standard form of the straight line equation, y equals mx plus c. M is the value that we are using in our angle of inclination calculation. So what is my m value for the first one? A half. For the second one, guys, is this one written in standard form? No, so I can't say what m is here. You first have to move the 2x to the other side and then divide by 5. All right, so for the last two, 2.2 and 2.3, first need to write those in standard form in y equals mx plus c, so that you can see what your m value is, and then you find the angle of inclination. So for these two, first write in standard form. Okay, so you're doing 1 and 2. Just going to zoom in a little bit so that you can all see all of that. Oh. Okay, guys, before you start working on that, I want you to get your phones out because I need you to sign up to the website. The website is reflectivelearning.co.za. Reflectivelearning.co.za. Show you what it looks like online.